So welcome everybody to another microservice meetup. This time we just try in advance, are there people in the room who do not understand German? Okay. So we're settled, we're stuck with English. We just tried whether it makes sense to switch to German, but we announced to have the talk in English, hence we will do it in English. Welcome to the meetup. Give a round of applause to Rio, who are once again sponsoring the meetup, serving you the beer and the pizza, and are also producing chaos all the time. So if you're into chaos, Rio would be a great employer for you. And I believe chaos engineering, or as Adrian Cockcroft is now calling it, continuous resilience, I believe is one of those new things which makes the life of the engineer more fun and the services more resilient. Therefore, I'm totally looking forward what Benjamin Wilms will tell us about chaos and how to inject failures to make our systems better. And you will introduce yourself.
Yeah, I will.
Looking forward to it. Welcome.
Okay, thank you very much. Do we need to start anything? Recording software, camera?
This one is started already.
Okay, so let's get started. First, I'm not a native speaker, so sorry for some grammar styling and so on. Who is already doing chaos engineering? Yeah? 1, 2, okay. Who is doing, or who's a developer? Who is an architect? Who is doing ops? Quite a lot. Wow, okay, very nice. Yeah, so let's get started. My name is Benjamin Wilms. I'm, co-founder, whatever that makes sense, of the Chaos Mesh. Chaos Mesh is a new startup where we are able to do some chaos engineering, and we are founded in October last year, so we are very young. You can see my slides in the back? Yeah, perfect. You can hear me also? Yeah, perfect. So if you have any questions later on, you can contact me by Twitter, by mail, by whatever. Contact formula. So, on the way to the most beautiful place in the world. A place where we normally are proud of. A place where we would like to invite our families, our friends, our family, our children. What I'm talking about. Any ideas? No? Nice place. It's called production, or production. A place where our applications should start immediately, should work as expected, and yeah, do that job. And what we are doing to go to production? Well, first we are writing countless unit tests to check our components. Are you doing happy path testing? Hands up. Yeah, normally that's a normal case that you are doing happy path testing. Do you have any hard quality gates, like a test coverage from 80%, 90%, something like this? Do you have a quality gate? Yeah. Yeah, afterwards we are doing integration tests where we are checking our components between each other. So component A is coming up and we are starting also component B to check if they can reach each other and do their job. And finally, some system tests or some manual testing and a lot of other bad things. Acceptance tests, performance testing, security testing, A/B testing. There are many testing types in this world. Who's doing all of these? Nobody? Good job. Who's doing testing the whole day? Yeah? I have worked for an insurance company near Cologne, and there's a whole department, about 80 people, and they're doing testing the whole day. From 9 to 5, the whole day. Not a such beautiful life. But there's one big problem. There's still this unpleasant feeling. How will our baby react under real conditions in production? Will it survive? Hopefully. And of course, is a life in production possible at all? Otherwise, this is production. This is your environment. This is your production. There are maybe some users inside this beautiful place, and should we be proud of this place? Not really, or? So, production hates you. All the servers hate you. All the routers, all the switches, all containers, Kubernetes especially hates you. So what went wrong? Do we know the cycle of death? You are just want to change a tiny little property in this maybe configuration on Kubernetes. You will deploy this new configuration. Bang! Something went wrong. And your system is collapsing. And you have some cascading failures. And you are now doing a post-mortem analysis. Are you in good conditions to do a good job on analyze? So, are you under stress? Maybe not, because it's production. Could you fix it the right way? Not really. So maybe you are covered by the cycle of death. Nowadays we are dealing with very complex systems. For example, that's Amazon. And we are building systems, applications on top of this Amazon infrastructure. Should work pretty well, no? Yeah. This is Twitter. Can you hear me? Yeah, can you hear me back? Okay. This is Twitter. If you just want to tweet one little tweet, this is the whole service infrastructure, whatever, stack. If you would like to watch a video at Netflix, that's the desktop of Netflix. But they are doing it pretty well, or? Do you have any problems to watch a video at Netflix? Besides German internet infrastructure problems. And of course, yeah, we are not Amazon, we are not Twitter, we are not Google or Netflix or whatever. We build and operate something like this. This is a picture from Instana that will show you a stack from our customer. And this customer, we call it, it's in the public transport sector. And they are building a new system, and that's their infrastructure. And they are also doing chaos engineering to handle this infrastructure. So we are not quite far away from Netflix, Amazon, and so on, if you take a deep look on it. And there's something more called dark net. Whoa, marketing, yeah. Do you know what dark nets are? Did you hear it before? So we have our technical nets, technical issues, and we are trying to fix them in this sprint. No, new priors, Prio, we need to do it in the next sprint. So we try to get these technical issues out of our system. But there are some other issues called dark nets. And dark nets are, how do we call it in English? Anomaly in the system. So if one tiny little component is collapsing, or there's a CPU overload, the whole system can collapse. And there are no metrics that will be able to show us this dark nets. If you would like to get more details about dark nets, just Google for John Alsbo, and he has written a very great blog post about it. What does it cost? An outage from infrastructure per hour. In most European companies, we are talking about 100,000 euros per hour. If you have a critical application failure and you need to fix, or you need to release a bug fix or whatever, we are now talking about up to 1 million if you have this failure in your system. So let's get started with Chaos Engineering 101. What is chaos engineering? First, there's a great free public available PDF written by the guys from Netflix, Casey Rosenthal, Robin Hostein, and Aaron, and of course Nora. And yeah, you can get it for free. So, any questions so far? No? Thanks for having me. Have a nice evening. No, just. Netflix is doing chaos engineering since 2010, 2012. And why did they do chaos engineering? Because they have a switch from a big monolith to an AWS microservice infrastructure system, and they need to handle all the outages, and they need to invest many time to get all the data out of the system. There are some levels where you're doing chaos engineering. Of course, you're doing it on the infrastructure layer, where you could kill a virtual machine or a host, where you could inject latency on the host level, or you can do some bad things in the platform, like a Docker or Kubernetes, or AWS or Azure, whatever. And you can also do it on the application level. So you are able to inject a specific latency in a specific application call, or you could throw an exception if somebody is calling this specific public message, for example. And of course, there are some soft limits or some soft levels where you are take a look at your company, your culture inside of your company, and how people are reacting under stress, and are they able to fix an outage in production, and so on. Did you hear anything about a game day? It's a good starting point. Yeah. Who's doing a game day? Nobody heard? Oh, okay. Normally you would start with a game day when you are starting chaos engineering, because you will invite DevOps development teams, you would invite operations, you would invite all the business departments and so on, and to discuss your system and to find some dark depths inside of your system. It's a good starting point because you are talking about your system and you are all sitting in one room, and you don't need to break something because, yeah, hopefully somebody is sitting in the room and is raising up his hands to say, sorry, if we are running this experiment, we will fail in our system. You got it? Yeah. It's my first talk in 2020. Wow, not so smooth, huh? Inside of a game day or inside of an experiment, we are creating an hypothesis. For example, if we are injecting latency in this specific customer service, we would like to see a fallback occurs. That could be a hypothesis. Or what should happen when we are throwing any kind of exception. Next, we are talking about blast radius. We are always starting very, very small. So, for example, you have a scaled service inside of your system with 10 instances. You would not kill all 10 instances. It's the first run. You would like to start with one tiny instance to kill it or to make it slow, whatever. And if the experiment will not fail, you could increase your blast radius. So first start with 1, afterwards with 2, for example, or 3, and then increase it. What the heck is normal? We are great to build big walls, video screens, Grafana dashboards, whatever, with some metrics and some values on it. But are we able to see immediately if our system is working correctly? Is it in a steady state? Is it working correct? Do we see the word normal? No. So now we are talking about a steady state. And a steady state is a simple metric where we are able to see if our system is working pretty well. And it's not more a technical metric, it's a business metric. For example, Netflix is using numbers, clicks on the play button. So they are able to see, they are able to know on a typical Monday morning at 10 o'clock, we have about 3 million clicks on the play button, and afterwards a video will start immediately. So if this metric is going down, the system is not working correct. And that's a business metric, not a technical metric. Another example could be orders per minute. So on a typical Monday morning, we have about 2,500 orders per minute in our online shop. And our steady state is this dotted line. If we are going down under this dotted line, our system is not working correctly. And we are able to compare all the values with some, with a big data store like from the last year. If you start any kind of experiment, please talk to operations. Please talk to your business department that you are doing chaos engineering. If you don't, they don't like it. And they will come to you. They will call you, they will send you some bad emails, and some other bad things will happen. So please talk about it. And why? Because when an ops guy is sitting in front of his desk and there are some issues or some events in the system, and his job is to fix it. But you are still just running an experiment and you don't know it, so you can't. So we start our experiment, but something went wrong. Our metric is broken. Our steady state is broken, it's not given anymore. So we need to stop our experiment immediately. If you are doing any kind of experiment, you need to design it in a way that you are able to roll back, to do the rollback. So if you are, there are some one-shots like shut down a host. We can't roll back it, it's not possible. But if you are injecting latency on the network layer, you need also to be able to do a rollback to get out of this latency. The cycle of chaos engineering. First, of course, we are creating any kind of experiment, like we would like to inject latency, we would like to drop some traffic to a specific endpoint, or we would like to drop the traffic is going to the Postgres DB or whatever. Then we are defining our steady state, so that we are able to see if our steady state is given. And we would not start any kind of experiment or any kind of attack if the steady state is not given. So if the system is not working correctly, it makes absolutely no sense to do an attack, to change something, to kill a host, to whatever. And not like unit testing, where you are mostly happy when you are passing a unit test. In chaos engineering, we are very happy if we have any kind of finding. So if an experiment will fail, we are happy because we have a new finding, and this finding will hopefully longer occur in production if we get it, if we find a fix for it. So if there are any kind of findings, like our fallback is not working correctly, or Hystrix is not doing its job correctly, who's using Hystrix? Who's using resilience for J? Who's using Java? First question. Okay. Did you hear anything about resilience for J? Yes? And Hystrix, of course, are also? Okay. Next question. Who's using Spring? Okay. Come back to it later. And that's, we are doing it continuously. So if an experiment has not failed, we are able to do it on every Monday or every hour to check our system. And if you already know your experiment will fail, don't do it. What's the learning? Nothing, right? Tool time. Some basic attacks, of course, shutdown reboot in a Kubernetes cluster on a node, very funny, or in a Kafka, I'm the new master, and so on. Who's using Kafka? Is it working correctly? Pretty well? Are you happy with Kafka? Yeah. Who knows stress CPU? With the help of stress CPU, you are able to increase the CPU load. You can do some I/O operations on the system. You can increase the memory. And you can do it in a controlled way because you are able to set a timeout. So please stress my CPU for up to 10 seconds. Afterwards, stress CPU will shut down and the system is working pretty well again. That's a rollback. Oh, who knows traffic control? That's an ugly tool. With the help of traffic control, you are able to set any kind of delay to a specific Ethernet device, for example. So in the first line, we are injecting to Ethernet 0, and the delay between 80 to 120 milliseconds. So that's our base delay plus minus 20 milliseconds to every protocol on this specific Ethernet device. You can do a packet loss. You can set, okay, please loss all traffic for 80% for whatever. And you can combine it. You can say, okay, please only do this attack, or please only do a delay on a specific IP and port combination. You can mark your packets as corrupt. You can duplicate all the packages and some other bad things. It's very funny. The hard way is to get it back, to do a nice rollback. Okay, who knows or who has used some tools from the Symian army? Okay, should I talk about the Symian army in general? Why it was born and why it started? Okay, so it was created by Netflix, and they started with a tool called Chaos Monkey. Chaos Monkey is a tool, and he's only just he's killing virtual machines at AWS, for example, in the first release. Later on, they are creating tools like Latency Monkey, Security Monkey, and finally, Chaos Kong. Who knows Chaos Kong? Who has survived Chaos Kong? Netflix. Chaos Kong is able to shut down the whole AWS region. Not whole AWS, more like the region from Netflix at AWS. And why they are doing this? There was, in 2014, there was a tiny little config change from one of the ops guys at AWS, and the whole region from US East, I guess, was going down because of this tiny little property change, or maybe it's in the Route 53 something went wrong. What happened? Amazon Prime Video was not able to deliver any kind of content, so nobody was able to stream any kind of video at Prime Video. At Netflix, they were able to deliver content. They were able to make their customers happy. Why? Because they have survived all attacks from the Chaos Kong. So they have checked in front of any kind of outage from AWS, what happens in our system, can we deal with this failure? So again, who's using Spring? Who knows this little monkey? One, okay, that hurts. It's called Chaos Monkey from Spring Boot, and that's my starting point, that's my project from 2018, where I started Chaos Engineering. So with Chaos Monkey for Spring Boot, you are able to inject latency in your Spring Boot application, you can inject exceptions, you can shut down your Spring application if somebody is calling a specific method, and some other bad ugly things. Who knows Pumbaa? I know it's a creature from Disney, but who knows Pumbaa? Nobody? Yeah, one. Pumbaa is an open source tool where you are able to attack the Docker containers. So you could inject latency in a specific container. You could also run Pumbaa as a daemon set in your Kubernetes cluster to kill some containers. So Pumbaa is also able to kill, stop, restart, pause, any kind of attacks through to your containers. Who knows this monkey with a banana? It's a funny name. It's called ToxiProxy. ToxiProxy is a component. It's a proxy, yeah. But why you should use a proxy? In some special cases, for example, you are doing your job in in team number 1, and you are using some services from team number B or number 2, and now you would like to check how your system, your applications is dealing with any kind of latency from the other team. So you are not able to get a deployment where everything went wrong in team B. So you are able to inject a proxy between these two stacks or maybe applications. But there's more. Well, we have found a new startup called Chaos Mesh, and I would like to do so. Stop it. Did you have anything from us? Who knows Chaos Mesh? Nobody. Great for a new startup. Yeah. Okay. So what we are doing? We are doing it in the way that we are able to. You are able to run some agents in your system. For example, if you have an AWS, Azure, Google Cloud, or you're dealing with some virtual machines, you are able to run our agent on your machine. If you are doing something with Docker, you are able to run it as a Docker container, or if you're doing Kubernetes at Azure, at EKS, at Kubernetes, at Google, whatever, you are able to run our agent as a daemon set. What we are doing now is we are discovering your system. So our agent is able to detect what's running on this specific host, what's running inside of this Kubernetes, on this Docker Swarm. Who's using Docker Swarm? Nobody. Okay. And we are collecting all containers running on the system, what are your incoming and outgoing connections, what are you running any kind of processes on the specific machine. And we are collecting it and we will sending it to our platform. Our agent is able to do an auto update, so you don't need to do any kind of new deployments, or if we are developing new features or bug fixes, our agent is able to do an automatic update if you want. So you are not needing or with any kind of configuration at all. And we have a big role-based concept about a team structure, so you will see it in a demo. Do you want to see a demo? Of course. Yes, thank you very much. Oh, fingers crossed, demo time.
Fingers crossed it fails?
Yeah. So our platform is able to run on-prem in your stack because chaos engineering can be critical. You're killing a container, you are breaking your system, and do you trust somebody that is hosting a software as a service platform and is able to do all these kind of attacks into your system? Not really, sometimes. So you could choose. We have a SaaS offering and we have an on-prem offering. And I would like to start in the back because at our team's configuration page. For example, you have a big Kubernetes cluster and you are running 20 or more namespaces inside of your Kubernetes cluster. And would you like to kill, or would you like, no, other way. You need to find a secure way that nobody is killing any kind of pods inside of your namespace. So you would like to find a way where you could secure your chaos attacks. So let's take a look at team number 1. You are able to set some restrictions. So for example, you could choose if you would like to restrict the kind of attack. In this specific case, we are able to do any kind of attack on all containers. So we are hitting many targets, but let's say we only would like to see, to kill some, let's say, fashion. Fashion is one of our containers, but we need to type it the right way. Fashion. Okay. I would like to hit all containers with the container name fashion. Now we have only got 4 targets. or I would like only to kill one specific pod. So I'm now able to kill 2 pods. This is unique ID, okay, yeah. And also I'm able to say, okay, you can inject delay, you can drop traffic, you can limit, you can pause, but please be so kind, don't do any kind of stress to any kind of my into my containers. So let's check again. No. If you have any questions, please feel free. So now we are doing a new experiment. Let's call it unique. You can define a hypothesis, and you can choose between some attacks. So we can do some kind of network delay on a specific container. We can do it on a host. We can do some stress with CPU, but we are not able to do stress CPU on container level. Because our team, we are now part of team number 1, is not allowed to do any kind of attacks on containers with CPU. Or you could change the state where we can pause a container, stop a container, or can do a shutdown on a host, or to stop a process. Any questions? No? And we have also integrated a simple steady state check. Currently a simple steady state check, but we are also try to integrate standard Datadog, AppDynamics, Dynatrace, and so on, so that our Chaos Mesh is able to trigger a webhook or to check in standard, for example, by the API, is there any kind of issue or is there an event during the specific time window. Currently, we are only just checking a specific endpoint if this endpoint is responding with a 200 HTTP code. Okay, so let's check Installer. Who's using Installer? Good. So now I would like to inject some CPU consumption on this specific host. That's the host name. To the right. Oh, sorry. Are we doing it live? Yes, we are. Open dashboard. Here you can see CPU usage. And now, come on. Create host CPU attack resource not container host. We would like to have a lot of 80%. This is our target. That's the part where our discovery data is coming in. So you know your pod name, you know your label, your AWS label, and to set it the right way. And we are now hitting one target. For all targets, we have more than one, and run. Fingers crossed. Okay, it's working. Yeah. Oh, yeah. And there's something more. A panic button, panic mode. So, for example, the ops guy is sitting in front of his desk, and there are some alerts or some cascading errors, and he would like to stop all attacks in the whole cluster, in the whole system. He's able to do it with our panic mode. And now nobody is able to run any kind of experiment because the system is not in a steady state. And yeah, also if you have some scheduled experiments, for example every hour, they would not be scheduled. That's another security feature. What else can we do? Should we take a look at Kubernetes to kill a pod? Yeah,
So why do we have the steady state in this Chaos Mesh UI?
The state. Okay. So if you have defined a steady state, and the experiment will be executed, it will first check if the steady state is good during the experiment run, and then every second or whatever you have configured, the Chaos Mesh platform will trigger this steady state check, for example, every second. And currently we are under discussion because we would like to get a pre-ramp phase where some steady state checks are doing more than once, and afterwards also, after the run-up experiment. Okay, let's take a look at Kubernetes. So, namespace, sorry, wrong way, namespaces, chaos mesh, pods, running, okay, everything's fine. Let's kill a pod. Kill a pod state, stop container. You could choose if you would like to do a graceful shutdown or immediately. And we would like to kill, again, our fashion. Oops, sorry, fashion. And we are selecting by container name. So there are 4 targets. This is a list of our specific targets. And now I would like to limit the blast radius. So maybe only 50%. So we are only killing 2 pods from all the 4s. From all. Save and run. Fingers crossed. Yes. Number 2. Okay. Good bug fix. Let's try another one. Kill exactly 2. It's working pretty well, yeah. Your startup. Oh, 2! Did you see it? Yeah. Okay. Last one. Any questions so far? Yeah, in the back.
How do you deal with auto-scaling effects?
Auto-scaling effects? How to deal auto-scaling is the question. So we are collecting all the discovery data continuously. Every 30 seconds or every 50 seconds, whatever you configure. And so we are able to handle this, of course, yeah.
So shouldn't there be a button to disable auto-scaling while doing an experiment?
Sorry, I didn't get.
Shouldn't there be a button to also disable auto-scaling to the full extent while doing an experiment?
It depends to your experiment, of course. You can do this. Currently, you would need to get some access to, for example, AWS to trigger stop autoscaling. To trigger stop autoscaling, it's currently not possible as a platform. Inside the platform. Yeah. Any other kind of questions?
So,
yeah.
Regarding the AWS tab in your system, what kind of targets can you attack there?
Many.
Okay.
Many. For example, not one. Sorry. Yeah. Oops. AWS, a whole region, for example. So if you click on this, you could kill all the containers that are located in this region. It depends on the attack. For example, we are doing stop container. If I are now doing shut down the host, there are 5 targets.
So that means you can attack on any container-based system, right?
Yeah.
Can you
And also virtual machine like EC2 instance and Fargate and whatever.
Okay, so you can also attack like high-level services, lambdas.
Lambdas currently not, but
in principle,
in the future, yeah, of course. And also, our agents are running as a daemon set inside of a Kubernetes cluster, and they are able to kill the underlying node. And fingers crossed again, shut down the host, EKS, node group number 1 is the specific name, 1 target, okay. Save and run, okay. Now take a look at the infrastructure. Whoop. So something should happen in the back. And thanks to EKS, EKS is able to see that there's an outage from the specific node, and it will spin up a new node. But it will take some time to get all the metrics into its data to see it. Okay. Any other questions? Did you like our product, Chaos Mesh? Yeah? Nice. Okay. So, yeah, let's wait just one minute, hopefully. See the shutdown. It's good when it's starting.
One question.
Yeah.
Do you have any feedback about how, what kind of findings you have by using the tool? So you use it probably at some customer side.
Yeah.
And what is the feedback? Does it find
Yeah.
a lot of issues?
Yeah.
Hidden issues?
For example, they are doing a rolling update strategy, and they would like to see what happens if something went wrong inside of the rolling update. That was one finding, that they have misconfigured ECS cluster. That was one thing. Or normally they would like to do Gatling, load testing, and so on, but they are not dealing with any kind of latency inside of the system. For example, if there is a tiny delay on the database, what happens in the system? Yeah. Did this answer your question?
Yeah.
Yeah. Okay. Any kind? Oh, it's gone. Yeah. Demo time is nice. Yeah. So AKS, not AKS, EKS should spin up a new virtual machine. Yeah.
So does it mean if I want to run it in my AWS environment, I can test only my environment? I cannot violently.
You're not allowed. You can use it on-prem inside of AWS, or you can use our software as a service offering, but still you are not able to kill any kind of other components from other companies.
This sounds like a tool that can be misused.
It's, yeah, you need to take care about it, of course, yeah. Yeah?
So it's agent-based, isn't it?
It's agent-based, of course, yeah.
Within a container is the agent.
You can run it as a binary on your host, on your virtual machine, as a container, and the container is running inside of a Kubernetes, of course.
Have you ever had questions about like compliance, security, auditing, and all these likes?
We are now in month number 3, no.
Okay.
Until now,
Yeah.
no.
So the controller is on the web, right? So basically the agent is currently like questioning
okay.
back and forth in this direction
Yeah.
to your main site.
So the general concept is our dedicated platform is, the other way. The agent is polling the platform. Do you have any kind of experiments that I need to do? And so there's no pushing inside of to the agent. So all the agents are polling to one specific URL. And the communication is secured, HTTPS, and if an agent is doing an experiment, he's creating a WebSocket connection. And if this WebSocket connection is breaking down during the experiment, the agent will automatically do a rollback. Did this answer some of the questions? Yeah.
Yeah, it answered a couple of questions, but so more. Like HTTPS, how to deal with proxies and stuff. And
Yeah. That's not how it's called.
So now I got a mic.
Okay.
Helps for the recording and for the rest of the audience.
Yeah.
Do you have anything more to show? Or yeah.
Or if you want. But,
Yeah, of course. What kind of experiments can I start from?
take
Your
a look.
tooling.
But there was one question. Huh?
So the question was basically related to my previous question. I mean, so if I understood correctly, the prerequisite for running this is have something container based, or is
No.
is it like the entire set of requirements, or do you need Kubernetes,
No.
or do you need any specific orchestration?
No.
runtime?
We are starting on a host, on a virtual machine. That's the starting point. And you could run our agent as a binary installation, as a service on this Linux environment. You could run our agent as a Docker container on this virtual machine, or you could run it as a container inside of Kubernetes. But the starting point is a virtual machine, a host.
And how do you deal with environments like hosting runtimes like ECS, for example, which is not Kubernetes based?
There you are able to, maybe hopefully you have a specific image that you are rolling out, and you are able
to install the agent on the host where the
On the base
container is
image.
going to be scheduled. I get it. Okay.
Yeah.
I guess I understand now.
Okay.
Thank you.
Yeah, next question.
Thanks. Is it possible to combine experiments? Let's say first go with CPU up to 80%, and then if above 80 also kill instance whatsoever?
It's coming. It's very, good question, because that's only the starting point. We would also like to do multiple attacks, like you explained. First CPU, and 10 seconds afterwards do some latency attacks or memory consumption and so on. Yeah, you are able to combine this, and you are also able. That's one of our cultures. You are able to see all experiments from your colleagues, but you are not able to run it. Only the specific team is able to run this attack because they are attacking their system. But you could you are able to copy it, to make a copy of it. So if they have created a great experiment from a Kubernetes cluster, whatever, you are able to do a copy of this experiment. And you also got a reporting view. So if an experiment was, for example, cancelled, like I did, or you would like to see what happens, you can afterwards see, okay, there was a shutdown on this specific host, that's plus values, and everything went fine, and you got no findings. Here you are able to, if you are doing a game day, you are able to insert some findings, or there's a action required afterwards, and so on. Yeah.
Do you ever have trust issues? I mean, I'm thinking if I had a company and I had really, if I had, let's say if I was Netflix,
Yeah.
but not with all the tools, I was just missing your tool. And how would I just trust that I would install an agent of a company that is 3 months into development of this agent, running all my nodes, and risking that it may suddenly go crazy and shut them all down? So I assume that you thought about it and you have answers. So in a way, the question is to see what do you have. So for example, do you recommend them not installing it on all nodes, or do you, because it's not it's not a mature software, but it requires to be installed on all my nodes and basically do whatever it wants to do to my nodes.
Yeah. We try to find the writing in our software. For example, now I'm doing a attack on the state and I would like to kill a process. So currently I would hitting over 600 targets if I press this button. But you need to take a look at the limit affected. So this is a mandatory field. You need to insert some values.
But what if there is a bug that suddenly starts crashing all the time? That's what so in a way, I'm trusting a software. So I'm thinking that if I hear about you, and if I have an already running company with lots of customers and so on, how would I trust running your code on all my nodes while knowing that your code can really bring me to my knees?
Okay. First, I would not start in production. Of course. Because you need to get all the insights from your application. You need to know how your application or how your stack will react to any kind of outages. That's the first point. And it's up to you. Yeah, sadly, but we take all the possibilities we have to do it the right way. But if you have a team designed that is able to kill all namespaces in your Kubernetes cluster, this will happen, of course. Yeah.
So you have not faced this as a resistance?
Until now, not.
No, from customers, wouldn't they ask you what guarantee do you have from me? For example, I could imagine that you would say, look, there is a safety. Or for example, we can formally prove that we will never crazily shut down your node. Or something that we can, because I understand that, yeah. If, for example, if you can prove that if there is no request sent from your server to a node cannot do anything, proving in a way softly. No?
Okay.
But the point is, have you been in that position to need to say that?
Until this moment, no. But what about a feature like you are creating a pipeline with experiments, and somebody in your company has to take a look at it before it will execute it? For example, we are also showing you the list of targets you are hitting now with this experiment, like 600 processes and so on. And so there need to be a confirmation inside of your company. Would this makes it better for you? Or
no, because that's my code, and then I can handle it. For example, I would never suddenly change. Let's imagine if I have 600 servers instances running. If I want to update my server, I would never immediately do on all 600.
Yeah.
But your code, in order to be able to use it, I need to have it on every node. So I need to trust already that your code, which is not my code, which does not go through my testing, is running on all my machines. And in the real case, probably I would like to have it in production because I would really like to see it eventually. So I'm talking already about that. So, and then I would be scared of having somebody else's code having so much control over my infrastructure. And hence I thought probably people already asked you about this. So how do you guarantee, how do you, for example, I don't have a business, but if I had, how would you somehow...
Could you use the microphone, please?
Oh, sorry.
I took him away.
Sorry. Short summary, I was basically trying to find out if there is a way to give some sort of peace of mind to a customer saying, look, it's okay if you put my agent on all your nodes, because when I think about it, I really like it, it's amazing, but I'm thinking I would need some sort of guarantee because it's not my code and it's not an open source project that is proven to be good for 5 years or so.
Yeah.
It's somebody else's code that especially has power and will be on all my nodes, because for example, even if I don't trust, let's say Kafka number 2 that comes out and it's been only a year, I can still do have some backup plans. What if that, and not everything goes on, but since I put your code on all my nodes, you can basically shut me down.
Yeah, of course, that could happen, but that's not the starting point. We would like to start small and increase. If you have the trust and confidence in our system, in our product, and then you could increase the blast radius on all agents. Yeah?
Yeah, just adding on it, very simple. Well, it's hard to introduce such a bug, but if you just use the wrong customer ID or client ID, and you send a request to kill all of the nodes of one customer to the one customer, you're essentially shutting down, well, the whole infrastructure of the wrong customer. So it's just, and you can't protect it, stuff like that with just reducing your blast radius. When another customer just wants to kill all his infrastructure, but you accidentally kill the other customer's infrastructure, that's an issue.
Are you talking about if you're running it as a software as a service or on-prem?
Well, the software service in that case, yeah, sure.
Okay. There's besides our agent, and we're going very detailed now, our agent and the platform, they are, have a specific certificate, and they are only able to interact with this specific communication.
So I believe just grab him afterwards and try to convince him to open source the agent or whatever is needed to get trust.
That was a great answer.
Yeah.
Okay. Is everything open source?
Really open source certificate.
Since you've never mentioned anything of open source or something like that, I assume that you're probably selling your product. How much is it actually?
Okay. At the current point, we are looking for called design customers.
Meaning you are giving it to any volunteer by free.
Yeah, for a specific time period to use it, to get started, to get some new insights, to get some new ideas, and yeah, that's the current state. We're not talking about any kind of pricing model. There is a pricing model, but not officially now. Yeah? 2 questions?
So how do you make sure that a stress test of memory or CPU doesn't kill the daemon? Or how does the network go through if you do network?
We are not running stress CPU in the same process or in the same container, and so if the system is detecting, okay, this is running out of memory or whatever, not our agent will be killed. And another process, another. Yeah.
Just a general question, because you mentioned about having customers can actually build pipelines around this. Do you have an API that we can interact with?
It's coming in the next 2 or 3 weeks, yes. There's an API you can use, you can interact in GitLab, whatever, yeah. And there are also some webhooks that you could use or you could trigger and so on, yeah. Wow, many questions. I'm done. One question.
Yes.
Also questions. Oh!
Is the system also usable for very old-fashioned systems like application server with no cloud connection, with no VMs?
Let me talk about the future. We are starting on a virtual machine, and we are scanning the processes that are running on the specific machine. In our pipeline, there's a new discovery called, for example, Java discovery, Spring Boot discovery, and so on. So we are able to see, this process is a Java application. What's the specific Java application? Is it a Kafka? Is it an Apache Tomcat? Is it a Spring Boot application? And this we are also able to attack afterwards. So I have created the chaos monkey for Spring Boot, and I'm able to do some bytecode instrumentation. So I'm also able to interact with your Java application to see some insights. It's coming here. And it's a USB. Yeah. Next question.
So what kind of attacks can you actually run on which layers?
Currently we are doing it on the infrastructure layer and on the platform layer. Infrastructure, virtual machine, process kernel, CPU, memory, and I can show you also some network attacks. For example, drop traffic. So that's a black hole attack, for example. You could drop all the traffic to one specific IP or host name. For example, also you could type in a host name for your database or whatever. Yeah.
So not yet, as you mentioned, no application level.
Currently not application level, but it's,
hopefully for Spring Boot.
Yeah, we would like to start with Java and Spring Boot and Kafka, Tomcat. Yeah, that's the next point of ours.
So I'm following up with a question. So you motivated quite well. Why to do actually chaos engineering and why to inject failures? You have some funny anecdotes. What actually was found out by those kind of tools? So because shutting down hosts nowadays on AWS as an auto-scaling group or on Kubernetes, hopefully this is Netflix pioneered this years ago, so this is not exciting anymore. But what else have you witnessed or have read about where you actually more difficult to find failure was in there?
2 short stories. First, running update. I was in the ops team from a customer, and I asked them, what are you doing? Are you doing running update? Yeah, of course. And is it working? Yeah, it's working pretty well. Everything is fine. Next question was inside of the development team. Did you have some Gatling load testing tools or any kind of load testing? And is it working like expected? Yeah, everything went fine. And the question was then, did you ever run a load test during a rolling update? No, never. And what happened? They failed. Very bad. They got about 30 or 40% of error rate in the system during a rolling update. And the second story is just a simple, absolutely simple Docker pause on an AWS ECS cluster. What happened? AWS, ECS is doing the job perfectly, everything is fine. ECS has detected that the container is paused and has spin up a new, with a new ID, everything is fine, but there was one big gap, the application load balancer, because it was configured, a request needs to be failed 5 times in a row, and the check is only triggered all 30 seconds. So there was a big gap, 2.5 minutes, where yeah, there are some big mistakes in the system. Yeah, short stories, boring. Okay, any other questions? Okay, so thanks for having me.